All right, welcome Blackett. Thank you for joining us today. This talk is called I Am the One Who Knocks. So my name is Igal Gofman. I'm the head of security research for an Israel-based startup, Hermetic. We focus on cloud security with a special focus on cloud infrastructure security. So 2 cents about myself. I've been doing security research for a very long time. Basically, my background is Windows exploitation, Active Directory, and threat intelligence. I love everything related to cloud security, and nowadays I spend most of my time researching the many cloud services out there. I also worked during the years of several large organizations such as Microsoft and Checkpoint, and spent a few years in smaller security startups in Israel. So this is my second time speaking at Blackett, and I'm super excited to speak in front of you. And I'll let Noam present himself.
Hi everyone. I'm Noam. I'm a cloud security researcher, and my background is in embedded devices and offensive security.
Okay, so actually this talk started based on a brainstorming session Noam and I had around one of the core services, the mighty IAM service, and how it differs in function from one cloud vendor to another. Now, before we start, just a little bit of context about why we think this is an important topic to speak about. We know that organizations deploy their infrastructure on a multi-cloud platform more and more these days. And the reason is there are times you want to lift and shift on-premises infrastructure, for example, to get redundancy, so you distribute it across different vendors. Sometimes you just want to reduce cost, or choose the best of breed service. So you may run your workloads on AWS, but for some reason the development team has a special requirement to use a specific database that only exists in GCP. Now, once you do that, you are now managing 2 separately cloud infrastructures, especially IAM infrastructures. Now, on the surface, it seems that all vendors give us similar set of management tools and core services that help us actually support us managing those resources in the cloud. But how actually does it behave under the hood? Are all vendors actually following the same rules, the same best practices? And are all vendors following the shared responsibility model in exactly the same way? Now, what about us, the security professional that need to manage the cloud? Do we really understand how each provider implements its own access model? And what are the do and don'ts of each platform? And it's hard enough to be expert on one cloud platform, but often we copy features and routines from one platform to another. And those may work differently from what we expect at the beginning. And we know that vendors spend millions, sometimes billions of dollars on securing their infrastructure each year. But how does it actually translate into better security posture on our end, the consumer side? If you think about it, IAM and all around IAM, actually none of those mistakes or weak spots that surround IAM are actually the cloud provider responsibility, right? It's basically all on us. We are, as cloud consumers, the one that accountable for that security. So if you're a Fortune 100 company, that's great. You probably have a dedicated security team for each cloud vendor. And even then, sometimes things can get a bit complex. So think about how users access different resources in the cloud. What about authentication and authorization logic, evaluation policies? What about internal service communication? So those non-human identities, non-human services that need to speak one with each other. Do we really understand how each vendor operates internally under the hood? And what are the risks involved in managing those managed identities? And what about encryption and encryption keys? Do we have full visibility into our multi-cloud platform encryption keys? And last but not least, what about logging? Do we log everything? How can we use logs to our advantage? Now, today we're going to focus basically on the hidden risk of managing a multi-cloud IAM environment. We will walk you through main differences between each cloud infrastructure and talk about the weak security spots of those platforms. And when I say weak security spots, I refer to infrastructure features that are shared among all vendors, such as permissions, non-human identities, default policies, etc. Now, we talk about several use cases and see how inconsistent entitlement actually can lead to unintended access, and what are the steps the defender can take in order to improve their overall security posture. Now, don't get me wrong here. I'm not saying other security flows are not used by attackers or are less important to protect against. But if there is one thing we would like you to take from this specific session, is that IAM is the backbone service. It is the core service. It is the gateway that controls every access to your cloud resources, and it must be protected. So let's begin. So let's spend 2 minutes on IAM. So at a high level view, IAM composed of identities, which is basically anything that can authenticate against the IAM service. And in addition, it provides us permission documents that define who can access what and under which condition. And each provider has its own unique identities and shares some of those between the vendors. So you have users and groups which are shared between all vendors, but also you have some special type of identities such as predefined groups in GCP, that those represent all authenticated users or project owners. So you need to be very well familiar with the infrastructure in order to make good security policies. Now, if we look at identities, we can break those to two main categories, human identities and non-human identities. Now, non-human identities today are very important to security. Actually, each vendor has its own implementation for non-human identities, and we'll mention those during the session. Now, if we put the major three providers, one against another, this is how the comparison looks like. On the left side of the chart, we have many different types of identities, and on the right we have those permission documents. Now, each provider uses some kind of permission documents, usually in the form of JSON, and those documents are linked to the identities we see on the left. Now, the linkage operation, sometimes it's called assigning or buying or attachment, but it doesn't matter. It's basically the same purpose, serve the same purpose. Now, the major difference, the first major difference between those vendors is that Azure and GCP follow what I call the classical role-based access model. So they allow you to limit the effect of each document permission to a specific scope. And this is a very important security enhancement. So for example, you can give someone administrative permissions, but limit the effect of those permissions on a certain scope. So in Azure, for example, you can limit those to resource group, or in GCP, you can limit those to a project. Now, in AWS, the scope is actually part of the policy itself, and it is much more limited and harder to manage, and usually based on some kind of string manipulation. Now, I'm not saying Azure and GCP have better policy capabilities because they are not. I'm saying that the way security is defined by AWS is way, way different from other vendors, and we need, again, to be familiar with those. Now, the second major difference is that AWS access model is heavily based on identity policies, whereas GCP is kind of resource-based driven, and Azure is a mixture of both. And the third major difference is that Azure and GCP are full-blown identity providers with full management capabilities, and AWS has something they call single sign-on, which is a bit of misleading name because single sign-on is not actually the main feature of that service. Basically, single sign-on is kind of mini directory within AWS. And if you are not using it yet, we strongly recommend you start using it because it lets you actually manage access to multiple AWS accounts in a much more convenient way. All right. So on the slide, we see how a typical organizational structure looks like among the three providers. And all vendors allow us to gather resources in the same way, usually in some sort of container for resources. So in AWS, the main container for resources is called an AWS account. And this is the small unit that can contain different resources. And you set up AWS account, and there, of course, you can provision resources and policies. Now, in GCP, the way this works, you have a main basic container, which is called the project. And you can roll up several projects into folders, and folders have a nested structure up way to the organizational resource. Now, Azure uses basic resource container, and it is called resource group. And every resource must belong at least to one resource group, and if not, Azure will make you create a new resource group. Now, if you have, again, a bunch of resources that serve the same application logic, you usually store and put those in the same resource group. Now, as I mentioned, Azure and GCP working a bit differently, and the main reason, again, they use scopes that restrict access to container in the organizational structure. So you can choose different scope. For example, in Azure, you can use subscription or management group, but in AWS, there are no scopes, so scopes are actually defined inside the policies. And now we're gonna talk about those during the session. All right, so now that we cover some basic IAM, let's zoom out for a second and think about the cloud infrastructure attack surface and why actually IAM permissions are so important. And most likely, many of you heard about the AWS role permission. And of course, how it can be abused by attackers. And actually, we had some breaches during the years that abused that specific permission in order to gain high privilege access to different assets in the cloud. But actually, how many of you can tell me what is the equivalent of pass role in GCP? If you are not expert on GCP. Now, it actually called the service account act as permission, and it is very, very similar to pastoral and can be abused in similar ways. And this brings me to my next point. So actually IAM infrastructure uses thousands, sometimes tens of thousands of different permissions. But actually attackers don't really care about most of these permissions. Usually they focus on management permissions. Attackers don't really care about implementation details or how IAM differ between cloud vendors. All they need is access to the IAM service, which of course publicly open to the internet. They need a security context, such as compromised credential or some kind of token. And they need a security context to have enough permission, so to be attached with the relevant permission documents. And then they can act on their objective. Now, if they don't have those permissions, they will try to privilege escalate, but usually looking for specific types of permissions. Now, when attackers or security researchers hunt for new bugs, they usually use specific exploitation techniques or chain of those techniques. And usually those techniques are very well documented into different categories. Now, if you think about permission, we can actually think about permissions and permission management in the same way, right? Because actually IAM permission there are some specific IAM permissions that are particularly interesting for attackers. And we can break down those to several subgroups. And the first group is assignment operation. So any assignment operation is potentially very dangerous and can be abused by attackers. The second one is code execution rights, and also we have delegation permissions and grants, which are specific to AWS, and creation of new credentials, and some routines around encryption. And on the screen you see several examples of those, and of course this is not a complete list, just to make a point. So assignment operation can be something really, really simple. We can assign, if we have assignment operation that allow us to assign ourselves to a new group, then we can privilege escalate and add ourselves to a high privilege group. But each cloud provider actually have specific and very interesting assignment operations that are unique for each vendor. So for example, in Azure you have some permission that allow you to assign a managed identity to a workload. Now, if that workload is compromised, attackers can assign new identity, new managed identity with potential high privilege permission, and without giving any secret, they can get the tokens that represent that managed identity. The second category is code execution rights. And there are different types of code execution routines. Some are simple, so direct code execution. For example, editing or modifying or creating a new serverless function and run those in some way. And in that way, you can again try and privilege escalate. Some not so obvious code execution routines is where you provide some kind of configuration file to the cloud provider, so infrastructure as code, and the cloud provider run those configuration files, those templates for you, and basically execute code behind the scene. And the last and my favorite, of course, is creation of new credentials. And you probably say, well, it's the oldest technique in the book, right? Why we even put that in its own category? But actually, it's used constantly by adversaries, and each cloud provider have a lot of different credential permissions that allow you either edit new credentials or edit credentials. And if you look at the SolarWinds hacks that happened 2 years ago, one of the main TTPs they used were actually adding new secrets to application, but nobody monitored that or noticed that. Actually, the attack was discovered from a different angle. All right, so let's shift gear and talk about something really important, which is non-human identities, which is a big topic by itself, and we don't have a lot of time to cover everything, but I'll do my best. So, non-human identities are actually a crucial part of every well-designed cloud infrastructure. And we see more and more cloud services that start actually adding support for those non-human identities. And vendors are pushing their users actually to use those managed identities, and for a good reason. Because it basically provides the cloud workload you're running the ability to authenticate, again, the IAM without storing any secret within the application logic or on the workload itself. So actually it's a security enhancement. Now each cloud vendor has its own implementation for those non-human identities, and some of the cloud providers has a very special implementation of those identities. But they all share, again, the main concept. So basically you can send an HTTP request from the workload and get a token back to you. And again, the only restriction is that you must run within that workload, whether it's virtual machine, container, or service function, it doesn't matter. You need to be on the workload itself. Now, so how does it work actually? It's like working like in a magical way, right? So actually, if you think about it, cloud providers need to store some kind of secret for those non-human identities. I love to call those managed identities the way Microsoft called those. So those managed identities need to have some kind of secret, but the secrets are not stored on the workload. They're usually stored in the infrastructure itself. Now, if we are not careful enough, non-human identities can expose our infrastructure to new risks, such as privilege escalation technique. And managed identities are tightly related to IAM permission because managed identities are actually authenticating directly against the IAM service, and they have some kind of long-term tokens, but those tokens are not located on the local machines. And here's a simple privilege escalation technique. So basically, if you have enough permission, we can initiate a new instance. And if we have assignment permission that we can assign new roles, attach new roles to that EC2 instance, we can pretty easily privilege escalate and get any administrative role we want and access different APIs in that specific AWS account. Now, let's think about hybrid managed identities. So this is a new thing that actually the cloud providers adopting it more and more. So hybrid managed identities or non-human identities are very special because, as I mentioned, there is a long-term secret that need to be stored somewhere. But when we are using hybrid instance metadata, when we are accessing and when we are running agents that represent those hybrid connections, actually the secrets, the long-term secrets are stored on the machine themselves, on your data center, because they're running, those virtual machines are running on your data center. So actually, when you are attaching managed identities from your cloud UI, you are attaching those to your hybrid instance, hybrid machine in your environment. Actually, the secrets, whatever its certificate or something else, are stored on your workload, and if those are compromised, of course, it can lead to potential risks. And with that, I'll have Noam continue the lecture. There you go.
So the next thing we want to talk about are defaults. And I titled this "Defaults are an Attacker's Best Friend," which is a little bit of a provocative title. Maybe some defaults are an attacker's best friend, but some certainly are. Before we understand that, we need to talk about why defaults exist. And different CSPs have a different approach to that particular question. The Azure GCP approach to a default is this is a prefab construct that you should absolutely use. You should select the right one, attach it to your scopes, use it with your identities, and go forward and be successful. AWS approaches defaults, at least in the IAM space, as a sort of starting point on a least privileged journey. They're a point that you start from and then taper down into a more least privileged situation. Whether you take the first approach or the second approach, when defaults are vulnerable, then their inherent property of being very, very common makes for a dangerous cocktail. And what we're going to see in this section is a selection of IAM-focused default risks. That's not to say that there aren't a ton of non-IAM-focused default risks, but these are the IAM-focused ones, or a few of them. So let's start with AWS. AWS managed policies. If you are not familiar with AWS managed policies are essentially JSON policy documents owned and managed by AWS, which you can simply attach into your identities. The issue with that is that if we understand how JSON policy documents work, then we understand that they have to be broad by definition because they have a resource field, and the value of that resource field can only be a wildcard, whether that's a full star or a path with some stars. This is because AWS owns the documents and they cannot possibly know the names of your resources in your account. Translating that into a few famously common managed policies that sometimes create vulnerabilities, which are quite common. We have read-only access. Sounds pretty innocent, right? You should be using view-only access and not read-only access, as read-only access gives data access to S3 buckets, data access to some storage services. So a common permission used by some third-party vendors, which is quite dangerous. CloudTrail read-only access. Again, you might be deploying this, not really experts on AWS and using this managed policy. But again, once we understand the internal mechanizations of a managed policy, we understand why this can't work. AWS doesn't know the name of my CloudTrail bucket. So they can only possibly put a wildcarded expression in there, which means that it grants S3 get object on every resource in the account. You can get every object in the account as long as you know the path. So again, understanding the underlying construction stops us from getting lost in translation and exposes these default risks. Same goes for pass role, assigning other roles or managed identities, permission modifiers, or assume roles, all of which can lead into direct privilege escalations because they're not least privilege scoped down. Moving on to Azure. So the first thing about Azure is I think Azure really believes in the sort of default role approach. It can sometimes be difficult to select the right one, but we see this in the custom role limitation, right? Azure has a custom role mechanism. You can use it, but you're limited to 5,000 per directory. So as a fully fledged enterprise strategy, it can be quite difficult to support. And attackers in Azure can leverage read permissions and the assignment permissions that Igal talked about in order to use these default permissions when they're not properly scoped to exfiltrate data and escalate privileges. The next thing we're going to talk about from an Azure standpoint is access keys, which are an IAM bypass that is essentially created by default by many storage services. Let's take a deeper dive into that. So I created this storage account. And immediately, without me doing anything, it created these two access keys. What are access keys? Well, they do basically what it says on the tin, right? They're a pair of permanent credentials that you're supposed to rotate, with which you can not only access read, have read access to data with a bypass to the entire IAM system, like just directly using these credentials. You can also have management and write access to data. So this gives quite large control of storage accounts, and the same goes for Cosmos DB. The same goes for Redis. Same goes for a bunch of other storage services. Now, if you look at the image at the bottom, they do give you this like checkbox to tick it off, to disable it. And they say, well, disable at your own risk, right? Because you might be breaking your system and disabling all your access. And then if you go into the Azure Docs, they give you a handy idea for how to fix this, which is we have this metric for transactions under specific authentication. Here I put SAS and access keys. And you can see how many access keys, how many times access keys were used. Sounds perfect. Turn on the metric, look for a flat, make everybody stop using access keys, look for a flat line, turn on the toggle, win. The problem with that is that I just created this bucket. And I never used the access keys. I just clicked. I never even clicked show on the access keys. I don't have the access keys, and yet we have access to this. The reason this is happening is probably, to our best estimation, because Azure is using these access keys internally to access your data. Like for portal display, for example, and other mechanisms, like the portal does break a little if you disable them. And by the way, when I showed this to Igal, he said, maybe it's just the creation, right? It's just like the bump for creation. No, it lasts all the way throughout. And the issue with that is that they're an IAM bypass that's very hard for defenders to notice, and it's quite hard to disable. You can do a deeper dive into the into the logs and look for all the activity and sort of like find whether your users are doing activity, but it's much more complex than an easy fix. Now on to GCP. So GCP has a sort of legacy concept from the olden days called basic roles, which is still quite prolific. Basic roles, viewer, editor, and owner. We focused on the first two. Have strong and broad permissions. How broad? Like you see the fancy numbers here on the right? But they're basically for all of the cloud platform. Viewer sounds, again, innocent, sounds like view only, sounds like metadata. No, viewer lets you query BigQuery. Like, for example, viewer gives you very significant data access. Editor basically is like a power user permission that you can escalate to admin if you're crafty and want to enough. And the way they scope it down in the compute engine in GCE is another older mechanism called access scopes, which is, the name is a little, maybe, like to me the name was a little confusing because it's not about scoping down to resources, it's about scoping down to APIs, it's about scoping down to services. So you take these access scopes, you just select out of the list that Google has, you take these access scopes, you attach them to the basic role, and the sort of intersection of those permissions creates a permission map. The third thing that's important to know is default service accounts. Whenever you turn on a service in GCP, unless you've disabled this behavior, a default service account is created. And the thing is, for many services, the permissions that that default service account has is those same basic roles. Viewer, editor, usually editor, or at least for compute engine, it's editor, are those basic roles. So the totality of this brings us to another kind of dangerous combination, which is if I started a compute engine machine, I got the default service account because I just clicked through, that meant I got the default editor role because no one edited the permissions for the default service account, which by the way you can and should do. And someone gave it the cloud platform access scope. This is like a mistake that someone needs to make, right? The default access scope is cool. It only lets you like write some logs and do some view onlys, and it's all right. But if you want the machine to actually do something, then the sort of docs way of getting you through that process without giving you an entire IAM course is they tell you put the cloud platform scope. Cloud platform scope is virtually everything. It's very, very broad. And so if you have the cloud platform scope, that's a privesc to project admin, and it's quite dangerous. Not even to mention, like, if this machine happens to be public or happens to have leaked keys or happens to be vulnerable or there happens to be a way of running code in this machine, in which case it's like a full account takeover vector and not just a PE risk in the environment. Next thing we're going to talk about is logs, and specifically that logs have limits. Now, logs are awesome, logs are incredible, and they are probably better than they ever were in the cloud. This is not like to throw dirt at cloud logging, which is quite good. But especially because it's good and we learn to rely on it, we need to understand its limits and be able to contextualize them correctly. Why is that? Because we use logging both, obviously, to know what's going on, do detection, do incident response, and that's not so much the topic of this talk, but it's incredibly important, and you all like live this and know this. The second reason we use logging is actually to build better permissions. Because in order to know whether I can take permissions away from someone, what I would usually do is try to examine the logs and see what they're actually using, right? A sort of use it or lose it philosophy. And if logs have limits, then I can't be sure enough that I can freely remove, and that leads to permission sprawl broadly. Also, attackers can hide behind unlogged APIs, opaque APIs, log manipulation, distributed logging. We're going to dive into that from a cloud service provider specific perspective. Last piece of like advice is log whatever you can, but then there's the parentheses, right? Log whatever you can afford to, because some logging for like data actions or data plane actions, some users or some organizations find prohibitively expensive, and that's perfectly understandable, and at the end it's a risk cost calculation that we're all forced to make. AWS. So a few like logs have limits points in AWS. There has been a long known passive reconnaissance technique for AWS for role enumeration. If you're not familiar with it, then absolutely look it up. But basically you can save IAM policies with a role and they don't agree to save if the role isn't real. So you can sort of do a brute force enumeration on roles and targets account. This has been known for a while. Data actions, again, because data action logging is quite expensive, sometimes it's not turned on, and then that can be leveraged to retrieve data. CloudTrail manipulation. So AWS has a really cool thing, which is the CloudTrail digest, right? It does like a hash checksum digest on the CloudTrail logs to show that nobody has manipulated them. But let's go back to the shared responsibility model. Whose responsibility is it to check the digest? That's right, me, you, us. Who actually checks the digest? The question is, not a lot of people check the digest. So an attacker can often go manipulate the digest, remove events they don't like by overriding if they've already like done a PE that's strong enough, right? You have to do it. and manipulate CloudTrail in some scenarios. Last thing I heard after we constructed this presentation at a conference 2 weeks ago, research by Kat Traxler from Vectra. I have the link here, definitely look it up. You can use S3 replication to do a cross-account data exfiltration, which isn't logged at the source account. So you can just leak out S3 data under certain conditions, like there have to already be S3 replications about the number of destinations. Won't go deep into that, but again, these vectors for unlocked data replication or unlocked data exfiltration are important in AWS. In Azure, so if you are familiar with the sort of Azure approach to logging, there's a central activity log which mostly only contains managed policies. The other logs are distributed, they're managed by each service. You sort of have to control which storage accounts they go to and gather it from them. There are Azure internal ways to like make this entire orchestra play together, but it's not out of the box in a way that like GCP and AWS are. And read actions are not logged to that central activity log, which means they're very, very often missed. Secondly, that issue of distributed logging, again, makes logs have limits and makes logging more difficult in that particular context. Sorry. The multi-cloud conclusion for this, whether you're already multi-cloud or considering multi-cloud or deciding to go multi-cloud or managing multi-cloud, is that multiple clouds multiply both log dispersal and the amount of languages that you have to process logs in, because all of this has different schemas, all of this has different abstractions, all of this has different meanings, and there's no one-to-one translation. Unfortunately, there's no magic solution I can offer on this stage to make everything magically better, but this is an important thing to be aware of, both when managing an environment and when making decisions and considerations strategically. So, this has been up until now has been well, I think a lot of, some of it has been like the classic black hat of, ooh, things are scary, be afraid. But then what can we actually do? What can we do practically to make things better for our organizations and for our defenders? I'm going to bring up 2 points here. One is pretty practical and the other is a little more philosophical, but bear with me. The first thing is try to limit the effect of mistakes, because IAM systems and all 3 of the vendors we discussed today are complex. And they're complex in different ways, they're complex to different degrees, but all of them are complex. And we find that organizations will make mistakes. And so one of the most important things is limiting the effect that a mistake can have. One of the things that can do that is sticking to one AWS account or GCP project or Azure resource group per workload. But again, don't get lost in translation. Why? An AWS account is a strong security boundary, relatively speaking. You can only do cross-account actions under specific precondition. You have to have bilateral permission, et cetera, et cetera, et cetera. An Azure resource group is only as strong as a security boundary as you make it. If you went to the higher organizational units we saw in the resource map earlier, like the subscription or the organization, and you gave permissions, then your resource group is not a security boundary. So understand when that's a security boundary and when not, and try to apply it in a way which actually limits mistakes. Deploy organizational policies to limit mistakes. So these are different in every cloud. In Azure, you can do something like organization-wide policies or deny assignments on the all principles principle. In GCP, you can use organizational policies. In AWS, the classic way is service control policies, or SCPs. A few examples of things that people like to do, which we think are good practice. In AWS, deny access to the root account, deny CloudTrail, delete trail, which is like the first step of evasion, no more logging, now we can do whatever. Or in GCP, we just talked earlier about the default service account plus basic role issue. You can actually disable IAM.automatic IAM grants for default service accounts, which disables that exact behavior. So you can protect yourself organizationally, and of course, avoid permanent credentials and secure human identities in as much as you can, because those are the primary entry vectors into any environment. Second point, which I said before, more philosophical, is about how do we build permissions. And building permissions is like sculpting. You can do it like clay or you can do it like marble. You can do it constructively, building block onto block onto block onto block until you have something functional that does what you need. Or you can do it like marble. You can take a big hunk of permissions and kind of chisel away at it until you have a form vaguely resembling least privilege. And clay building is something that I think security teams like and developers hate, right? Because I don't know yet what permissions I need, and I'm not the IAM expert, so I can't tell you exactly which permissions I need. And so the challenge of that is knowing exactly what you need. And the risk is dysfunctionality, lack of flexibility, reduced velocity. So all of these are the reasons to not do that. Marble, the challenge is to prove a negative, just like we talked before when we were talking about the limitations of logs. You need to be absolutely sure that someone doesn't need a permission before you remove it, otherwise you will make a lot of people very upset. But the risk of that is that you end up being over permissive. And in fact, the sort of thing we find most common in actual practice is people take the big hunk of marble, kind of promise themselves to chisel away at it someday, and then never actually do, or at least don't in the really painful and substantial areas, like the pass role, the act as, the assignment permissions, you know, the places where privilege escalation or all these permissions that Igal showed before that actually hurt you. Our recommendation is kind of boring here, which is a hybrid approach. Try to not place hunks of marble that are too large. Like, don't start from the biggest power user permission you can get from that service. Try to place smaller blocks and then chisel away at them, because then if you didn't get to chisel, at least you don't have a larger danger looming over you, and also you are controlled for mistakes, and you are and sort of in line with that, and to make the sort of clay sculpting or hybrid sculpting process easier, we built a tool called AccessUndenight on AWS. It's an AWS tool, as the name implies. And it came from the issue that some deny messages are not detailed. Actually, AWS has gotten much better with it. To begin with, a year ago, none of them were detailed. Now some of them are significantly more detailed, but still none are fully detailed for security reasons. And so if you don't know why you're getting a deny, then A, you're very frustrated, but B, you don't necessarily know what permission to add. And what that leads to is permission sprawl, because under the pressure of usability, again, you add a big hunk of marble, it works, and now not only does it work, you're kind of afraid to touch it, right? Because it didn't work before, and now you did the thing, and now it works. And so that's exactly how permission sprawl happens. You do something, then it becomes the thing that works, and then you don't touch it anymore. So what AccessUndenight does is it scans the whole permission landscape. It scans the SCPs, the permission boundaries, the identity policies, the resource policies, and then it runs a permission simulation to tell you whether it should work or not, and scans the policies to tell you what sort of statement is the one causing the deny, or what statement do you need to have an allow. And we're going to have a demo. Before that, the demo starts from already having the CloudTrail event. There are reasons why we did it this way, namely that when things are happening from service sources or not from your particular machine, then CloudTrail is the only centralized location where you can see all, right? Not all, but the most of the things that have happened. So imagine that we already ran S3 list bucket. We tried to list the objects in a bucket. We got this access denied message, and now we are going to run the tool. So I apologize for the text size, but I will do my best, football commentator narration effort. So we start with the CloudTrail event that we saved into a JSON file. It's called access denied CloudTrail event. So let's look at that file, see what there is in it. If you are not versed in the sort of arcaneness of CloudTrail events, it says access denied and not much else. It says the source account, the action, but not why access was denied. So now let's look at running the tool. Before that, let's look at the sort of commands that are available. We have two commands. One is called analyze. It does the works. It analyzes the CloudTrail event, tells you why access was denied. Another one that's really helpful is get SCPs. It just downloads the service control policies so that it doesn't have to do it every time again and again and again, because it's quite a heavy burden in terms of APIs. So now we ran an analysis here to make it quick for the demo. I ran it without service control policies, so you're going to see the little warning. There it is. And we have the response. So basically, under assessment result, we have, it's a missing allow and an identity-based policies. So we don't have a deny, we're just missing an allow. And then we have where we need to attach a new policy. That's RN AWS IAM account ID. And see, I got the account ID scrubbed because I know some of y'all have plans. And then the policy that we need to add, which is allow S3 list bucket and do it for this particular bucket. So now you can add the least privilege policy and avoid the kind of sprawl that happens. This was a very simple example, but it also works in complicated cases, right? That's just one tool. I think there's an incredible world of tooling. These are mostly the IAM tools around AWS. The reason they're AWS-centric is because both the power and complexity of AWS IAM, I think, invited this concentrated community effort to make an open source stab at this issue. I think spaces like Azure have incredible tools for like pen testing or red teaming or Active Directory, but not particularly tools in this space. So Policy Sentry lets you sculpt out of clay by specifying your policies in CRUD. IAM Live monitors what APIs are running on your machine and does a similar thing, which is tell you the least privileged policies you need to add. And there's a bunch of tools that scan your CloudTrail and your environment and tell you which policies are safe to remove because they haven't been used, like Cloud Tracker, RepoKit, and a bunch of privilege escalation tools, which are the rest of the ones in there. And without any further ado, we're happy to take questions. Thank you so much for listening.